Welcome to the Deep Dive. This week we are digging into the AWS updates from, let's see, September 29th through October 3rd, 2025.
Yeah, and it was quite a week. Not really flashy headlines, more like fundamental plumbing getting sorted out and some real steps forward in tooling.
Exactly. Lots of infrastructure work, lots of maturing developer tools. So our goal today is really to filter through all that noise and pull out the updates that actually give you, the listener, more control, better security, or, help you scale more efficiently.
And looking at the sources, two big themes just jump right out. First, this massive, almost relentless push towards IPv6 across it, like nearly everything core. It's not optional anymore.
Right. You can feel the pressure from IPv4 running out and those compliance deadlines, like the U.S. federal one.
Absolutely. And the second big theme, it's the rapid maturation, maybe even professionalization of the whole generative AI stack, specifically Bedrock and the agent core stuff. It feels like it's moving from cool experiment to, okay, production ready.
Totally agree. So yeah, let's focus on those building blocks, the things that let you build reliably and securely. Maybe start with the AI and machine learning side, because the new models plus these integrated agent tools, it feels like a real shift in automation potential.
Sounds good. So raw power first. Anthropic's Claude Sonnet 4.5, it just hit general availability on Amazon Bedrock.
And the positioning there is interesting. They're really pushing it for complex tasks, coding, things that need longer reasoning chains.
Exactly. And the key metric they're highlighting is its performance on SWE Bench verified. For people maybe not deep in the LLM benchmark weeds, SWE Bench is tough. It's all about fixing real GitHub issues, actual software engineering problems.
Okay.
So Claude 4.5 leading there means it's genuinely good at those complex agent scenarios and what we often call long horizon planning.
Long horizon planning. Unpack that a bit. What does that mean in practice, like for a real system?
It means the model can handle a project with multiple steps, where, maybe an intermediate step fails or it needs to remember something from way earlier in the process. Think about an agent trying to diagnose a bug across several microservices.
Right.
It needs to generate code, test it, maybe deploy it all in one go, potentially over a long interaction. That usually trips models up.
Yeah, the context window gets filled, or they just sort of forget what happened 5 steps ago. How does this new Claude version handle that?
So 2 really interesting features in the Bedrock API for this. First, Claude can now automatically edit its own context. It can basically clean out old, stale info from previous tool calls to make sure the important stuff stays in focus.
Yeah.
And second, there's a new memory tool. This lets the model explicitly store information and then consult it later outside the main context window. So it has this persistent memory.
I see the benefit right away, better accuracy, probably less hallucination if it can look things up. But is there a trade-off? Like performance, if it has to keep calling out to this external memory, does that slow things down compared to just having it all in context?
That's always the question for production, isn't it? Yes, there's some overhead for that external call, but you gain 2 big things. One is cost, because you're not constantly stuffing huge amounts of maybe redundant context into every prompt.
Good point, though.
2 is reliability. Retrieving from a structured memory is often more dependable than relying on the LLM's internal recall across many steps. So yeah, it's that classic trade-off, maybe a bit of latency for better stability, scale, and potentially cost.
Okay, that makes sense. And speaking of structured reliability, the whole agent ecosystem got a boost with the GA releases for the Model Context Protocol servers, right?
Yes, exactly. The AWS API MCP server hit v1.0.0 GA. This is like the crucial bit that translates natural language, what you ask the agent to do, into actual syntactically correct AWS CLI commands, and then it executes them. So the agent can talk to basically any AWS API.
Any AWS API.
Yeah.
Which is incredibly powerful for automating operations. But it also, really changes your security thinking.
Yeah, that was my next thought. If an LLM can just generate and run commands, how did the GA release address the security validation side of things?
That's a huge focus. The GA release notes mention improvements in security validation, faster startup, streamable HTTP transport. But the fundamental principle is still the same. The LLM operates with the permissions of the IAM role it's running under.
Right.
So the responsibility really shifts to you, the user, to be incredibly careful with the principle of least privilege for those agent roles, because now they can potentially do a lot.
Okay, meticulous IAM hygiene becomes even more critical. And to keep those powerful agents grounded in reality, there was also the AWS Knowledge MCP server hitting GA.
Yeah, update 36. And this is key for enterprise use cases.
Right.
It anchors the agent's reasoning in authoritative AWS sources, the official docs, AWS blogs, well-architected framework, things you actually trust. So when it suggests, say, an architecture change, it's basing that on AWS best practices, not just, something that's scraped off the web or overheard in Slack.
Exactly. It improves consistency and makes the agent's reasoning much more trustworthy. You know where its knowledge is coming from.
Okay. One more on the AML front before we shift gears. OpenSearch Ingestion adding batch AI inference support. This sounds operational, but why is moving from real-time to batch a big deal for folks with large data sets?
Oh, this is potentially a massive cost and performance win. A lot of people were doing inference in their real-time pipelines using the existing AI connectors for Bedrock or SageMaker, which is great for low latency.
But expensive if you're processing terabytes of data constantly.
Exactly. And often unnecessary for bulk enrichment. Now, you can use those same connectors, but in a batch mode within OpenSearch ingestion pipelines. Think about generating vector embeddings for, your entire historical data lake.
You wouldn't want to do that in real time.
Definitely not. Doing it offline, asynchronously in batch, is way more cost-effective, and it doesn't clog up your critical real-time ingestion paths. Huge for large-scale enrichment tasks.
Right, solving a big cost headache. Okay, so let's talk infrastructure fundamentals. You mentioned IPv6 at the start. It feels like this week it really went from being sort of a compliance checkbox to a core architectural feature.
It really did. It was the infrastructure story of the week, I think. You can see the influence of things like that U.S. federal mandate, OMB M2107, pushing for IPv6 by 2025. But the updates were broad, hitting really foundational services.
So for anyone running containers at scale, the headline must be Amazon ECS now supporting IPv6 only tasks. What specific problem does getting rid of the IPv4 dependency solve there?
Private IPv4 address exhaustion. It's a genuine crisis for huge organizations. Before this, even in a dual-stack VPC, every single ECS task needed an IPv4 address assigned to it just to function.
Right.
Removing that requirement means these large container shops can scale their fleets way beyond what their internal IPv4 ranges would allow. You can now run tasks purely in IPv6-only subnets. It cleans up the networking model and removes the whole complexity of managing dual stack just for basic connectivity. And it works for both Fargate and EC2 launch types.
That's huge for containers. But what about other services? Historically, things like storage, directory services, they've often lagged behind on IPv6, forcing people into complex NAT setups. Do we see movement there, too?
Oh, yeah. The migration is definitely comprehensive now. AWS Directory Service, for instance, now supports IPv6 and dual stack for both managed Microsoft AD and the AD connector. That's a big help for simplifying network upgrades, especially for Windows-heavy environments.
And crucial stuff deeper in the network, like key spaces for Cassandra and FSX for file storage.
Both got the IPv6 treatment. Amazon Keyspaces now has dual-stack endpoints, and importantly, that includes support when accessed via private link interface VPC endpoints, which is critical because many orgs access services only privately.
Makes sense.
And similarly, Amazon FSX for NetApp on NTAP and FSX for Windows File Server both now natively support IPv4, IPv6, or dual-stack access.
That native support is key, isn't it? Because it leaves you don't need to stand up and manage separate, clunky address translation gateways just to let your IPv6 clients talk to your file shares.
Precisely. It gets rid of that operational overhead. And one more piece for secure access. EC2 Instance Connect Endpoint now supporting IPv6 too. This means admins can securely SSH or RDP into instances sitting in private subnets using the instance's IPv6 address.
Without needing any public IPs or bastion hosts that might only be IPv4.
Exactly. It really streamlines secure administrative access in modern networks.
Okay, so IPv6 is definitely becoming pervasive. Let's shift to operational efficiency, things that remove that undifferentiated heavy lifting. There was a potentially big one for container orchestration, Amazon ECS managed instances.
Yeah, this is interesting. It's like Amazon taking the Fargate philosophy where AWS manages the underlying compute and applying it to EC2 instances that are actually running inside your own account.
Okay, wait. If they're in my account, how managed are they really? Like, where's my responsibility stop and ECS's start, especially thinking about patching and security?
That's the key distinction. You still own the instances. They're in your VPC. You control the security groups around them. But ECS takes over the operational burden of provisioning the right instances based on your task needs, vCPU, memory, scaling rules, and then configuring them, operating them, placing tasks optimally.
And the security part, patching.
Critically, ECS enforces continuous security patching on these managed instances. They've set a schedule, I think it's every 14 days.
Wow, okay.
And you can use standard EC2 event windows to control the timing of that maintenance if you need to align it with your own processes. So you get the cost structure and customization potential of EC2, but you offload the day-to-day grind of keeping the underlying compute healthy and patched.
Interesting. Okay. Shifting gears again, maybe to the high-performance computing side. AWS Parallel Computing Service, or PCS, saw a bunch of updates focused on Slurm control. It feels like they're trying to make the managed Slurm experience less of a black box.
Yeah, the theme there was definitely flexibility, specifically without needing to rebuild your whole cluster just to tweak something. That was a major pain point before. Now, with dynamic cluster updates, you can change key Slurm settings on the fly.
Like what kind of settings?
Things like accounting configurations, some basic operational parameters. You can modify them without tearing down the cluster, without interrupting running jobs. Much more agile.
And the level of customization expanded quite a bit too, didn't it?
Oh yeah, they added support for over 60 more Slurm parameters. This is really aimed at large research institutions or places with complex HPC needs. It lets you fine-tune things like queue priorities, preemption rules, set up advanced quality of service levels, and basically much deeper control over how jobs are scheduled and resources are allocated in a multi-user environment.
Right. More knobs to turn for the power users. And for just day-to-day stuff, the ability to use control reboot now seems like a small change, but probably a big time saver.
Absolutely. Before, if a compute node got flaky or needed a quick reboot for some reason, telling Slurm to down it often triggered a full EC2 instance replacement, which takes time, costs money.
Yeah.
Now you can just issue control reboot, the node reboots in place, rejoins the cluster quickly, much faster for troubleshooting or minor maintenance, less disruption, lower cost. And they also threw in support in parallel cluster 3.14 for the latest big GPU instances, the P6e GB200 and P6e B200 types, keeping up with the high-end compute needs.
Got it. Okay, let's wrap up with data integration and governance, new ways to move data, but also, crucially, new ways to control who gets to see or analyze it. On the integration side, AWS Glue can now write data back out.
Yeah, using those sauce connectors. This is about closing the loop on ETL pipelines. Glue has always been good at pulling data from SaaS apps like Salesforce, Marketo, HubSpot, SAP. But getting process data back into those systems often meant writing custom code, like Lambda functions.
Right, more Glue code, ironically.
Exactly. Now, Glue ETL jobs can directly write data back using connectors for SAP OData, Marketo Engage, Salesforce Marketing Cloud, and HubSpot. So if your job identifies hot leads, you can update their status right back in Marketo or Salesforce directly from Glue. Much simpler end-to-end flows.
Okay, that streamlines things. Now, turning to governance. AWS Clean Rooms got something called data access budgets. Sounds like finance, but it's actually a privacy feature.
That's right. It's a technical control to give data contributors more confidence. It lets the data owners set explicit limits on how many times their data can be queried or used in analysis, whether that's SQL, ML inference, whatever, within the clean room collaboration.
So I could share some sensitive data with a partner and say, okay, you can run like 5 ML training jobs on this, total, lifetime.
Exactly. You can set per period budgets, daily, weekly, monthly, or a lifetime budget. Once that budget is exhausted, further analysis is blocked until the budget period resets, or if it was a lifetime limit, it's just done. It makes privacy guarantees much more concrete and technically enforceable.
Interesting. And Clean Rooms also expanded its reach with cross-region collaboration.
Yeah, this tackles a big compliance issue, especially for global companies. It lets partners collaborate on data without moving it across regional boundaries. So say your team is in US East, but the data they need to analyze with a partner is legally required to stay in EU Central.
They can collaborate without actually copying the data out of Europe.
Correct. The analysis happens within the clean room framework, respecting data residency rules. Huge for meeting GDPR, sovereignty requirements, things like that.
Okay. And just to button up the security aspect, VPC endpoint policies got rolled out more broadly across storage and transfer services.
Right. This is all about fine-grained control over how services are accessed privately through VPC endpoints. AWS Transfer Family, Data Sync, Storage Gateway, they all now support endpoint policies.
Meaning admins can lock down exactly which API calls are allowed through that private connection.
Precisely. And they added new IAM condition keys, for instance, with Transfer Family, allowing you to enforce policies like only allow SFTP configuration or prevent creation of public-facing server endpoints entirely. It tightens the security posture significantly, especially for compliance-sensitive environments needing things like FIPS 143 endpoints.
Okay, that covers a lot. So bringing it all together, it was definitely a dense week. Lots of investment in those core infrastructure pieces, IPv6 everywhere, network expansions like Cloud One and GovCloud, but also that very rapid evolution of the Gen AI tools, making Agent Core feel much more real.
Yeah, and the common thread I see is this dual focus on automated management like ECS managed instances, taking away operational load paired with really granular control like the clean rooms budgets or those new IAM keys for endpoint policies. It's about reducing risk while letting technical teams actually scale things faster and more reliably.
So here's the thought to leave you with then. Given just how many services got native IPv6 this week, ECS doing IPv6 only, FSX Directory Service key spaces, is it maybe finally time for organizations starting fresh, doing greenfield deployments to just skip the hassle? Should IPv6 only VPCs become the default template now, leaving the whole legacy overhead of IPv4 address management behind entirely? Something to chew on.
Definitely something to think about.
All right, thanks for joining us for the deep dive.